Hey classes, welcome back. Going to be talking a little bit about the review that we've been doing this week. As we have next week off, this was a good week to kind of recap some of the places we've been, some of the places we're going. So let's jump right in, try to keep it to the 10 minutes. We are using, once again, this rock right here, sedimentary rock known as coal. This particular one from West Virginia, from my grandparents' backyard back there. My grandfather was a coal miner, and we are using part of this to go along with the movie October Sky. Now, there is a text that goes along with October Sky. It's actually based on a book by Homer Hickam called The Rocket Boys. We're talking about the movie version of it, kind of a classic to use in middle school and high school classrooms because they talk often about the scientific method when they're talking about this movie. We are touching on that, but hopefully we've got a good grounding in the scientific method and the engineering design process. So we're talking a little bit more about the Carboniferous period, when this stuff came into being, or at least started on this path to coming into being, and a little bit about how it all ties together with what we've been learning here. So let's slow down and check it out. Way back in the early part of this class, going back, 22 weeks now, we were talking about atoms, molecules, how atoms are put together. And you may remember we talked a tiny bit about radioactive decay as well. Why did we talk about that? It keeps coming in again and again. For example, we use radioactive decay when we're checking out the age of fossils. You use radioactive decay across the hall quite a bit when they talk about carbon-14 dating and you're talking about artifacts. Also, one of the handouts that you can see here on the website shows the shifting continents. Remember, our Earth is kept warm on the inside. Those convection currents that run plate tectonics, well, that heat comes partially from radioactive decay of elements. So that was important to know about. What's driving our planet? What's making the rock cycle go? When you're checking out about the 1940s as well, and this will come into play with our movie, you might remember Twisting the Dragon's Tail. They talked a little bit about how they were using uranium and plutonium to make atomic bombs right towards the end of World War II. The little tiny clip that we are showing tomorrow from the movie Oppenheimer gets to that point. How does that fit in with our movie? Well, if you check out October Sky, it takes place in the 1950s in a place called West Virginia. And my dad grew up in West Virginia, and his father, being a coal miner, they had pieces of coal lying around the backyard. And when you look at the coal right here, think about what this is made of for just a second. This right here, this piece of coal is carbon. Well, looking at our chemistry from the beginning of the year, we look at our photosynthesis equation, CO2 plus H2O making sugar and oxygen. When you're looking at the moving continents and a place where there's been repeated burying of forests, as took place during the Carboniferous period, around 300 million years ago, you're looking at carbon that, thanks to photosynthesis, has been taken out of our atmosphere. We had oxygen being tossed off into the atmosphere, being really discarded by the photosynthesizers, but the carbon that was in our atmosphere, the CO2, is taken out. When you look at this piece of rock right here, you look at this piece of sedimentary rock, you're looking at essentially frozen carbon. And what we're doing when we're burning coal, when we're burning oil, oil was produced a little bit later, more during the Mesozoic, but when you're looking at these, what we call sequestered, just means buried, fancy word for buried, buried carbon deposits, what we're doing now is very quickly releasing this carbon back into our atmosphere, and that's heating things up again. We use the analogy in class of the infrared radiation being kept in our atmosphere much like blankets on a cold night. When you're cold, you put on another layer, you put on another blanket. Carbon dioxide is a lot like that. It's like adding another blanket and keeping yourself a little bit warmer on a cold night. Methane, which you get into a little bit later, is also an important global warming gas. And then further, we learn a little bit about carbon dioxide in our atmosphere because when we get into our ocean unit more deeply in March, we're going to be talking about the carbon dioxide that we're adding to our atmosphere, also getting mixed with our oceans and causing a drop in pH in the oceans, causing what we call ocean acidification, which is not good for any ocean life that depends on shells. So when we're looking at the burning of coal, the burning of oil, we're looking at a lot of chemistry and it ties in with everything from radioactive decay to what we're doing to our atmosphere right now. Also, when you check out a little bit about the story of October Sky, it's taking place against the backdrop of the Cold War. Remember, in the Cold War we had in the 1950s especially, the 1960s especially, a little bit of anxiety going on about the launching of Sputnik from the Soviet Union, Sputnik 1, circling the Earth. We started thinking, well, wait a second, if they can launch a hunk of metal that can go into orbit around the Earth, what is to stop them from launching, say, a nuclear bomb that can go across from one continent to another? Of course, that did eventually happen, and we're going to learn a little bit about the tie-ins there, again with the movie October Sky, about how intercontinental ballistic missiles, ICBMs, came into play. And right here in the Bay Area, right up on the ridge tops, just behind the school right here, we had Nike missile sites, nuclear-capable missiles that were designed to intercept airplanes that would be coming in should hostilities ever break out between the then Soviet Union and the United States. So there's a lot of interesting social and political tie-ins. And of course, our bent is the science here. So you want to check that out. Well, let me turn this off for just a second. And if you look at today's review started with Newton's laws. You might remember we did a little bit with Newton's laws way back when we saw Mark Watney, the fictional astronaut that was stuck on Mars. Newton's 3 laws of motion are really the basis for a lot of the high school physics that you're going to be learning. Our quiz, to get to the nitty-gritty about, hey, what's on the next quiz, will really cover the review that we did on Monday, Tuesday, and Wednesday. Not so much today, but I did want to make sure that I did a quick review today because, of course, we're getting you guys ready for high school and beyond. And remember, Newton's laws, inertia, force, mass, acceleration, and action-reaction. We're looking at the 3 laws that really were going to be forming the basis for a lot of your high school. And when we're getting into, okay, how does this relate to the Rocket Boys, to October Sky? Again, remember the Rocket Boys was the name of the novel. October Sky was the Hollywood adaptation to that. But there's a lot going on right here. Remember, it all comes back to baseball. When you're looking at Newton's laws from the movie version, we're checking out how Homer Hickam and the Rocket Boys in the movie version used a little bit of physics and a little bit of calculus to show how they did not start a forest fire that they were accused of starting in the movie. They were thought in the movie that one of their rockets misfired, landed and started a forest fire, and they were showing, using just a little bit of algebra, not too much different than what you're doing right here in 8th grade, how it wasn't possible for them to start the movie. As an inspiration to going beyond the algebra that you're going to be learning here, to go beyond the algebra that you'll be learning in high school, I wanted just to throw in a plug for taking calculus, the hard math. It sounds really, calculus, that sounds scary. Calculus was brought to us partly by good old Newton himself, Isaac Newton. But if you look at calculus, if you're thinking about a rock like this, say this is a meteor flying through space. As it goes through space, is force, mass, acceleration, it's got a constant mass. As it hits our atmosphere, of course, friction will cause it to heat up, and you might see something like this streaking across the sky. Something this large right here would make a pretty tremendous fireball in our night sky. When you think about calculus, well, when you think about a rocket, for example, a rocket has fuel in it that's constantly getting burned. You've got a good action and reaction example here for the movie and in our notes. But as the fuel is getting burned, think about the rocket for a second. It's losing mass as it goes. So unlike something that's traveling through space, it has a constant acceleration, say, and a constant mass, a rocket is constantly changing its mass. So given a certain acceleration that's coming out, say, from the engines, well, the mass is getting less and less as it goes, so it should be going faster and faster. So the point of that is, all calculus is like algebra set in motion. So I don't want you to be intimidated when you hear the things like trigonometry, differential equations, and calculus. It's really not that bad. At first, when I looked at it, I'm like, I'm never going to learn that. That's impossible. And then after you jump on into it, it's really honestly not that bad. So I want to encourage you guys, when you get to high school and beyond, take the hard math classes. Right here at our school, talk to Ms. Capella, talk to Ms. Weideman across the hall, the math teachers here for 7th and 8th grade. They'll be able to help you out and let you know what you need to do when you get to those math classes in high school. So that's a quick recap on our watching of October Sky. I hope you're liking it. Certainly, when you look at the coal mining in West Virginia, what you're seeing in the movies that takes place in the 1950s, it honestly, from my experience, still looks very much the same in places like West Virginia in the modern day as it did back in the 1950s. We are still getting the majority of our energy in the world from digging up this sedimentary rock right here and burning it, breaking those carbon compounds and getting the heat energy, transferring that to, say, electrical energy. And when you're going down the road, you got to remember this is a finite resource, so we're going to have to be looking down the line towards, okay, how are we going to get the energy that the world needs to continue with transportation, to continue with the energy needs that we have right now, when this right here is being used up at the rate it is, and also the environmental issues that come with taking this carbon and very, very quickly, in a relatively short amount of time, throwing it back up into our biosphere. With that, I'll let you check out the notes online. Have a good week off, which is coming up, and we'll see you back here.